One more thing, Daniel, that might assist in understanding this problem, and it's something that the gentleman mentions in the first video that I've sent you. We know that our point B, as soon as I actually get a pen that works, our point B here has a force in compression acting up to it. Okay, so we know this actual particle, or this part of the member, every single joint has to be in equilibrium. So if we have a force acting up and pushing it this way, we have to have a force acting down this way to compensate for that. We know that a force acting away from the joint is always tension. Okay, so you were saying compression for this particular joint because you ended up with a positive value, and therefore if we're looking at y, that's up, positive, and that's down, that's negative. And using that idea, what you need to remember is that when you use this method and you assume the joint is in tension, when your result is positive, it's in tension, okay, regardless of its positioning in space. Because if this wasn't in tension, like I said, if we had compression, we'd have two forces acting up. And would that be an equilibrium situation? I think not. So that might be another thing that you might want to consider when trying to understand this problem. But like I said, you need to trust the method, and the method is start with an assumption that everything is in tension. If you find a compression, reverse your arrow, and then you are looking at directions for everything coming in and out. But when you actually resolve your answer, when you come to an answer, if it's a negative, it's compression, and you write compression next to it, and you change your arrow direction. And if it's a positive, you're going to write tension. Have a look at the video. I'm 100% certain about this aspect of the problem. I wish I could explain it better than that, but it's very complex. So have a look at the video, watch the video, and if you still disagree with me, we'll have to sit down and have a longer conversation about this. But I'm going with what's been said in that video, and I've also done a number of problems. And if you work through some problems that have solutions using your methodology, you'll very quickly find out that you're getting the wrong answers. So that's another way of just affirming that you need to, like I said, assume tension, resolve your answer, and if it's negative, it's compression, pushing towards the joint, and if it's positive, you are correct in an assumption that it's tension and it's pushing away from the joint. Hope that helps.